Part 2. Let's talk about tangents and tangent segments. Okay, so again, I have a circle because this is our circle chapter. Okay, and we said that a tangent line the line is tangent to a circle. It's going to touch that circle in just one point. Okay, so that's just our definition of a line being tangent to the circle. Okay, but the other thing we then know about it is, let's find the center of my circle here. Okay, if I have the radius from the center of the circle to that point of contact, that's going to be perpendicular to the tangent line. Okay, so the tangent line is perpendicular to the radius at that point of contact. Okay, so that's another very helpful thing. If I have a line that's tangent to the circle, I know that I'm going to form a right angle here between the radius and the tangent line. Okay, other things that we know with our tangent line. Okay, so let's say if we have tangent segments. Okay, so, well, here I already have a line here that's tangent to this circle. Let's draw another line that's tangent to that circle from the same point. Okay, so you can see here they're coming from the, originating from the same point. So if I have two tangent segments here, okay, these we're looking at tangent segments. And so if I have two tangent segments tangent to the same circle from the same point, I know that those tangent segments are equal. Okay, that's a very helpful one. If I have two tangent segments to the same circle from the same point, those tangent segments are equal to each other. Okay, so I know that it's perpendicular to the radius at the point of contact, and that two tangent segments from the same point are equal to each other. Okay, very, very helpful information there. Okay, so then another thing that we had, not related to tangents, is about intersecting chords. Okay, so I have a chord here, and I have another chord here. Okay, so they're intersecting. So my intersecting chords theorem says that if two chords intersect in the circle, the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So here we said this is because we form similar triangles, and with those similar triangles, we are then going to have proportional sides, not equal sides, but proportional sides. And when I work out that proportion, what I'd end up doing in that proportion is cross multiplying. So that I end up doing this part times this part is equal to this part times this part. Okay, that's the proportion that I end up with. If I were to make triangles, basically if I drew lines here and here, and I get similar triangles here. Okay, if you remember why we have similar triangles there, just draw those little triangles real quick. Okay, clearly not equal triangles. Okay, but I have vertical angles here, so I know that those angles are equal. And then again, I have inscribed angles. Remember, an inscribed angle is going to have its vertex on the circle. So you can see this vertex on the circle, this vertex on the circle, vertex on the circle, vertex on the circle. So I have inscribed angles here. Okay, so with those inscribed angles, I know that this angle and this angle are equal because they both intercept this arc. Okay, and then I know this angle and this angle are equal because they both intercept this arc. Okay, so I have three angles equal here. So that tells me that the triangles are similar. Remember our angle similarity. If I have two angles that are equal between the triangles, and the triangles are similar. So the triangles are similar, that means their parts are proportional. So then if I set up that little proportion, I would end up with this side times this side equals this side times this side. Well, if we look at it in context of chords in this circle, that means the product of the parts of this chord is equal to the product of the parts of this chord. Okay, so you did these in your summary and review and in your homework. So if I have two of these chords that are intercepting, let's say this one is 4 and this one is 5 and this one is 10. I want to figure out what this one is. Okay, I would say, well, 10 times 4, look at this chord here. The product of its parts, 10 times 4 is 40. Okay, so then the product of these two parts of the other chord has to be 5 times x. Okay, so then that tells me that x equals 8. Okay, so that's how I would, oh, you can't even see that, sorry. Okay, so 10 times 4 is 40, so 5 times x also has to equal 40. That's basically what the intersecting chords theorem says. Okay, let's see. Anything else that we are missing? Remember, anything from previous chapters still be helpful to you here, like right triangles. Nothing crazy with right triangles, but you should remember your Pythagorean theorem and how to find your sides of a right triangle. That might also be helpful for you. The last thing is probably from your chapter 13. Nothing crazy there, but we had inscribed versus circumscribed. Okay, this circle is inscribed around this polygon. Okay, the circle is inscribed around the polygon. However, if I had a circle here, okay, this circle could be, and so we could say that this triangle is circumscribed. We could also have, if we had lines that are tangent to each side of this circle, then that would form an incircle. Then we would say that the circle, well, imagine that's tangent. We would say that the circle is inscribed in the polygon, and here the circle is circumscribed about the polygon. Okay, so inscribed versus circumscribed. That's really all you need from chapter 13, is just what you did. And look at that summary and review, the couple of problems I gave you for the summary and review for chapter 13. That is really all you need from chapter 13 for this particular test. Okay, so tangent segments, intersecting chords, central angles, secant angles, inscribed angles. Just make sure you work through that whole summary and review. Just think carefully on your test. Draw everything out as clearly as you can for me. Label things if needed. And I think that should be it. Let me know if you have any questions as you are working through your summary and review. But I think everybody should be fine. Okay? Y'all have a wonderful afternoon.